DataKinetics. I'd like to welcome you to this session this morning on Analyze IT. Just before we get started, I can see a few last-minute people just joining us. So we'll just give them another 30 seconds, a minute, just to join. So if you just bear with us. Hoare from DataKinetics, and I'd like to welcome you to this session on Analyze IT DB2 performance. I have with me Dr. Larry Strickland, who's the Chief Product Technology Officer at DataKinetics, and he will be taking us through Analyze IT today. As you can see in front of us, here is the agenda that we're going to cover. I'm going to do a very short company overview because we want to actually get and have a look at the product. We'll talk about what the purpose of the product is in Analyze IT, the benefits, how it works, what you'll get out of it, what your expectations are. Then we're going to go and actually do a demonstration. So you'll actually see the product live in action, and then some of the results that we'll get out of that. Next slide, please, Larry. Seem to be having a little bit of technology issues here. Thank you. DataKinetics, the company, we've been around for more than 35 years. We're based in Ottawa in Canada, and globally lots and lots of the companies know us and use our products. Some of the statistics we've got there: 3 of the top 5 US banks, credit card companies, property and casualty insurance companies. Just looking at a list of some of the people that have registered and have logged in for this. Some of you are actually using some of our products as well. And as we said, a fair, 20% of the Fortune 50 companies. We did an exercise in the office the other day about how long we've actually been working with these companies, and it's a scary number, well over 1,000 years. And most of us, except the ladies, have grey hair or no hair. Next slide, please, Larry. Here's some of our users. Some very, very well household names: WellPoint, Visa, American Express, Schwab, Kmart, government organizations, and we cover just about all of the vertical markets. So, if you're not sure whether you are one of our users, just let us know. We'll certainly let you know. Larry?
Thanks, Brian. So the main purpose of today's webinar is to take a look at a product called Analyze IT that's great for analyzing some performance bottlenecks within DB2. So the tool itself has a purpose to provide significant operational cost savings, looking at enterprise scale, data-intensive applications. Obviously, the more data-intensive an application is, the more opportunity for savings. What we find when customers use this tool and apply it against their existing systems, typically looking at performance gains in the 20 to 30% area, as in actually reducing MIPS or MSUs in that order. And then when that is the case, you typically need to see a return on investment substantially less than 1 year. The tool is not intended by any lengths or means to replace existing DBAs, but rather empower those DBAs to focus and look at the correct areas to improve performance. Some of the benefits of the tool: it actually gathers a large amount of information and puts it all in a set of reports that are at a user's fingertips. This can avoid a lot of manual work or other work that's used, analysis that's done in order to gather that data and do the in-depth analysis. This is all automated process, giving the correct information in the appropriate time in the right person's hand. So can collect detailed performance analysis, One of the other things we find is often it'll help gain access to lost knowledge when people have retired, moved on, left the company, etc. Some of their pieces they've left in terms of how data is accessed in DB2, that information is lost. The tool helps rediscover a lot of that knowledge or helps you work on performance issues without needing to recover all that knowledge. Takes advantage of the application packages in order to improve use. One of the other things the tool can be extremely useful for is to identify areas where DB2 upgrades have added new features or changed capabilities so that you can improve performance. And actually it's probably one of the areas that it's most commonly used is taking advantage of DB2 version upgrades by being able to analyze all the existing SQL and indexes and whatnot and make recommendations as to where those new features of DB2 can improve performance. This is not a monitoring tool. It is an analysis tool. It analyzes information in the structure of the DB2 and the SQL. And as a result, it's able to be reactive in nature. It doesn't, anticipates problems. What it's not doing is waiting to see a performance problem and then help you analyze it. It'll actually help you analyze before the performance problem actually hits a production system and gets you directly to the root cause. So how the tool works? The tool works in basically 3 steps. First step is to gather data from the mainframe. So this is typically in the DB2 catalog tables, such as the metadata, both logical and physical, the application access information in the plan tables, and the SQL syntax. And one important thing to note, this can be collected from both static and dynamic SQL environments. It's also possible to gather other inputs from the mainframe, such as performance reports coming off a number of different performance tools. These can be also collected at the same time the other information is collected. This information is loaded into the tool. If the tool then runs an analysis, and depending on the size of the data loaded, that can take a short time to a longer time. Running it overnight for a substantial database would be abnormal. And then what the tool's output is going to be is a set of reports that are going to cover a number of, provide potential performance issues and a number of recommendations across a number of different areas, including indexes, the structure, the query access, SQL analysis, and statistics that have been generated within DB2. So that's the process of how the tool collects and analyzes information. The outcome of that analysis is we'll analyze all application components. As I mentioned before, this will apply across both static and dynamic SQL access to that database. It can be integrated with monitoring data, which improves the recommendations and priorities provided to the recommendations. It will identify suboptimal DB2 model structures, code patterns, or SQL code patterns, and database usage. Can be used against the history, so logging and tracking of the index changes. And then it'll make a series of recommendations. So these are typically remediation steps, suggest a priority, assist the user in the evaluation decision process by enabling a user to go in and look at all the indexes applied to the index optimization that can be applied to a particular program or the number of programs impacted by a particular index, etc., to provide all the information in one point to help with that evaluation process. The nature of the recommendations that allow incremental implementation. This isn't a big bang where all changes have to be made in order to see gains. Each of the changes can actually be made over time, and gains would be also made over time as a result. The product output, as I mentioned, there's a number of reports that come out. I describe these reports as interactive, and what I mean by interactive is you can drill down within the reports, so from a SQL statement to a table to an index, etc. You can filter, and I'll actually show an example of this later, where you can actually do the analysis by program or by index. Very useful if somebody's going in there and wants to say, well, I'm going to be modifying this program. The tool can actually show you all the potential performance gains that could apply to that one particular program. Obviously, grouping can also be achieved. That's where you're going to have multiple programs as opposed to one. So now I'm going to go through give you ideas of what some of the example reports are. For example, under query access, which is one of the 5 areas it analyzes, the tool will do a table-based scan. So this looks at the scan chosen by the optimizer within DB2 and can make recommendations with regards to new indexes that would optimize that scan. Another report is the non-matching index scan. So this looks at the scan chosen, again, by the DB2 optimizer, and will recommend any changes to index or queries to improve things. A low cardinality scan, another report, identifies as indexes with a low cardinality that could be modified to improve the scan. So restructuring the index might improve your cardinality and therefore reduce the number of scans that the DB2 needs to go through in any given query. Queries with sorts, so identify sorts in queries as a result of the structure again. So by modification of the index or the SQL, you may be able to eliminate that sort and therefore improve the performance. These are some examples of the query access area. So here's an example of a report looking at queries with a sort. You can see this is looking at the particular, the current index, the columns included, and here's the SQL statement on the right-hand side, and you can actually see the matching columns is 0 in this particular case, and as a result, DB2 has to do a full sort in order to retrieve this, and with that impact, you have poor performance, so maybe a different index could improve matters. Looking in the next area of reports, indices. So one report provides missing columns for index only, so looks at the where adding an additional column or columns to an index will allow queries to complete by just reading the index. And the advantage of this is an index-only read is much faster than one where you have to also touch the full table as well to read data that's not in the index. So this identifies areas where this technique could be used to improve performance. Next one, looking at indices with identical columns. So by reducing the columns, since there's identical columns within the index, you can reduce the size of the index, which will also improve performance because the amount of data that needs to be accessed is lessened. Looked at unused indices. Obviously, removing those can help with storage space. Low cluster ratio indexes, so identifying where a different cluster index can improve performance. So looking at those cases where, again, a different cluster index would change that ratio and as a result improve the performance. So here's the example for the first of those reports, missing columns for index only. You can see in the up here, here's the index within the, here's the column within the index, and the advantage of adding this column would enable this query to go ahead with a retrieving data just from the index without the need to go to the full table. Another area of reports is the structure of the DB2 systems. So, for example, there's a report that provides table spaces with more than one table. If you can restrict each table space to one table, you can gain performance. Another report, tables with no unique indexes. A lack of unique index can result in performance degradation, particularly with regards to updates to the table. Tables with no cluster index, again, it helps performance improvement if you can get the right cluster indexes in place. Table spaces with a lock rule not equal to any, a scenario that should generally be minimized. It doesn't mean you shouldn't use it. This report just identifies where that's occurred, and consider whether there is a exception where that should be the case or not. So here's the example of the tables with no cluster index. Obviously, you can go and look at those in more detail if a cluster index is desired. Another area, example reports, looks at SQL issues. So the SQL issue report identifies a number of SQL conditions that are raised and may require investigation. So example, the use of exec SQL lock, the use of union, where maybe union all should have been used, where distinct is not in a cursor, where in subselect is used, current date not in the systummy1, and date timestamp calculations are made. Obviously, areas where removing these could improve performance. So there's points at all these so that they can be investigated. So here's an example of distinct not in cursor, the particular one selected. So it's just an example. I'll actually show a few more of these in the demo. So the next area of reports is related to the statistics. So one of the challenges that the optimizer may face is if it doesn't have a current set of statistics, it may not provide the optimal path in retrieving data. So the number of reports it goes through, so tables with no statistics or indices with no statistics, and obviously tables with old statistics, so areas where the statistics should be rerun, and obviously indexes with old statistics also. So now if you just bear with me a moment, I will bring up the application so I can demonstrate it. Okay, so this is the tool up and running. On the right-hand side, I actually have a list of all the reports. These all come up as a result of running the analysis, and the analysis is run just under Actions there, Run Analysis. And then when I've got a set of reports, I can just click on the report and view it, and you can see the number there at the end, which actually gives you an indication of the number of potential open issues against that report. So if I look at the unused indices, this report will give me a list of all the unused indices. And I can filter if I need to look at any in particular. I'll run through a few reports here. So I'm going to close this window over here just so you can see the full size of the screen. So this report is the queries with sort. So I can go into more details. Again, the reports are all interactive, so you can drill down. So I can look at this one in particular, look at the current index that's being used, and drill down and look at this particular usage in detail. So the query 243 in this case. And you can see the number of matching columns in this case is 0, which is causing the DB2 to go through a full sort in order to collect the data required. if I then go and actually look at the recommended indexes, I can actually find that same tool, that same index. So this is the looking at the same one, almost the same one. And this is the index in use, and it's comparing it to the recommended index. And if you look at the where clause down here, you can see why this would actually be the recommended index as opposed to the current index being used, and that should improve the performance on retrieval on this particular query quite substantially. So this is the types of things the application can identify. So some other reports. The low cardinality scan shows those tables that have that using the low cardinality. A non-matching index scan, and I can expand on the details. I can see here where the scan is not giving me a matching index, and therefore it is inefficient. So those are mostly the SQL query type issues. The examples of SQL issues. So here we have a number of issues that have shown up in the use of SQL, and again we're looking for particular type scenarios. So where I don't have distinct in the cursor, or where I'm using union instead of union all. And lastly, another example, which is where I am using the in case. So looking at some specific customers, examples of the use of this tool. There was a large European bank, unfortunately I'm restricted to give you the name of that bank, a large European bank that applied this tool, followed its recommendations over a period of about 3 to 6 months, and was able to reduce their DB2 MIPS consumption by 32%. In this case, that was millions of dollars savings and a very successful return on investment. Obviously, results vary based on the size of the system. A large telecom company in North America actually had an even more substantial gains, reducing their SIU by 64%. Unfortunately, again, I am not allowed to give the name of that company. And that completes my presentation.
Thank you very much, Larry.
Thank you, Larry. Are there any questions from anybody? If you notice down the bottom, there's a little chat box. We've got a question coming through here. The slides will be sent out to everybody, and you'll get those in the next 24 hours, probably later this afternoon. The question about how is it priced, it's actually priced by the number of users, and I can quite happily pass that information out when I talk to each one of you, because I will be doing some follow-up.
So Brian, it's priced by the number of users and the number of tables being used.
Correct. All right. Any other questions? I've got a question coming in here. When it is running, can you show us a live analysis? Larry, can you take that?
a live analysis. So the tool actually runs offline from the mainframe. So the analysis is done offline. Is that, I'm not sure the point of the question, a live analysis. That.
Okay, the full question was, what does the analysis look like when it is running? Can you show us a live analysis?
Oh, so if I just run an analysis, this will take a few seconds because a particular demo database isn't big, and that's it. That's the analysis. And what it does is, as it's running the analysis, it populates these various reports, and will give you these, as the analysis runs, you actually see these numbers populate as it runs through each of the reports.
Excellent. Any other? Hopefully that answered your question. Any other questions? Yep, good one. It did answer the question. What is needed on the mainframe for this installation?
So there is a extraction script that runs on the mainframe to extract the data from DB2 that's required. And if you're using the performance output of a report such as AppTune or Detector or something like that, you need to pull that report off the mainframe as well.
All right. Any others? Is it a start task or packages and programs?
It's a package and program that does the extraction. This tool itself runs on a Windows platform off the mainframe, so it runs as a tool within the PC. It's not, doesn't run anything on the mainframe when the reports I was going through there, nothing was actually running on the mainframe at the time. So.
All right. Coming thick and fast at the moment. Any other questions? All right, well on that note I think we'll wrap this up. On behalf of DataKinetics, I'd like to thank everybody for their attention this morning, and as I say, I'll talk to most of you over the next 24 hours. Thank you again for attending, and I'll speak to you all very soon. Bye-bye.